In this video, I'm going to go over a very much simple way of differentiating implicit functions. And let's get to look at the first one. If we've been given the implicit function y to the power 3 plus x to the power 2 plus 2 is equal to, let's say, x. How do we go about this one? Well, we need to get to understand that an implicit function is a function which is not written in terms of y is equal to f of x. So what we mean by y is equal to f of x is you can have y is equal to maybe x squared plus 5x plus, but here you see y is not the subject of the formula, so such is an implicit function. How do we get to go about it? Well, all we are going to do is we are going to take d over dx, that is the derivative of this function, y to the power 3 plus x to the power 2 plus 2 is equal to x. Now what will this give us? The first thing that we're going to do is just the way we know it, y to the power 3. What is the derivative of y to the power 3? We know first we get to multiply the whole function with the power and then reduce the power by 1. So this is going to be 3y squared. But every time that we differentiate y, we are going to add a y on top there. So it's going to be dy over dx. And then next, we are going to differentiate x squared, and that is going to give us 2x. Every time that we differentiate x, we add x on top there. Now that will be dx over dx. We know dx over dx is a 1, so we don't just add that one. And then plus, we get to differentiate a 2. Whenever we differentiate a constant, you get a 0, and that is going to be equal to differentiate x here. That is going to give us a 1. At this point, I'm going to take everything that doesn't have dy over dx to one side. And so that is going to give us 1 minus 2x. Therefore, dy over dx here is going to be equal to 1 minus 2x and then divided by 3y squared. So that is going to be the value here. That is going to be the derivative. Let's look at another practice question. What if we are saying we want to find the derivative of x squared plus 2xy and plus y squared is equal to 2? Well, in the same way, we are taking d over dx, the derivative of this function. And so we first get to find the derivative of x squared, that is a 2x. Now if we can look at this, we have got a product. First I can factorize out a 2 like that. Now we have got a product of x and y. When we have got a product, we maintain 1. Let me maintain x, and then we find the derivative of y. The derivative of y, whenever you're differentiating just x or just y, you're going to get a 1. But every time you differentiate y, you add dy over dx. And then plus. Now at this time I'm going to maintain y, and then find the derivative of x, and that is going to be a 1. And then we're going to close there. Plus the derivative for y squared, that is a 2y. Every time we differentiate y, we add dy over dx, and that is going to be equal to the derivative of a constant, that is 0. So at this point we're going to have 2x is equal to, we come to simplify this, that will just be x dy over dx, and then multiply by 2. So that will be 2x dy over dx, and then we have got 2 times y, that is going to be a 2y, and then plus 2y dy over dx, that is equal to 0. I'm going to put everything that has got dy over dx to one side. And so which are those? I've got this one and also this one. Now you can see that dy over dx is common on those two, so I'm going to factorize out dy over dx, and what I'm going to remain with is a 2x plus a 2y, and that is going to be equal to, now I'm going to take these two terms the other side, and they will become negative 2x minus 2y. So that means dy over dx here is going to be equal to, I can also factorize out a negative, and then we're going to have 2x plus 2y, and then we are dividing by 2x plus 2y. So we can even see what is happening here. This thing and this thing is the same, so it will just give us a negative 1. That is the derivative for that one. Let's look at another one. if we have 5xy minus, let's say, y to the power 3 is equal to 1, how do we get the derivative for this one? Well, just as we've been always doing, d over dx of this function. And here we also have a product, so let me first factorize out a constant. I'm going to maintain x, differentiate y, that will give us a 1, and every time we differentiate y we add dy over dx. And then I'm going to maintain y and then differentiate x, and that is going to be a 1. And then minus y to the power 3, the derivative of that will be 3y squared. Every time we differentiate y, add dy over dx, and that is going to be equal to 0 because the derivative of 1 is a 0. And so this will give us 5x dy over dx plus 5 times y, that will be 5y, minus 3y squared dy over dx, and that is going to be equal to 0. So this point, this one has got dy over dx, this one has dy over dx. I'm going to put them together and factorize out dy over dx. So that will be dy over dx. We are going to have 5x minus 3y squared, and that is going to be equal to, I'm taking this the other side, so that will be negative 5y. Therefore, dy over dx is going to be equal to negative 5y divided by 5x minus 3y squared. So that is going to be the value for that one.